Hello and welcome, dear friends. In this video we are going to talk about the button component and its properties, including buttons navigation. At the end of this video I will tell you how you can detonate several bombs by clicking on the image object that doesn't have the button component attached to it. This will help us understand the Unity event class. Okay, let's get started. So there are several objects and a canvas in this scene. Most of the objects are disabled so far, I will activate them later. In addition to the canvas, we have a single enabled object that has the button component. The image component stores the button sprite and its raycast target is equal to true. Let's start with the interactable property. Interactable determines whether or not this particular button will accept input. In other words, if this property is true, then the button will respond to clicks. If this property is equal to false, the button will not respond to clicks. Just make sure that there is an event system object in the scene. It's important since the event system object is responsible for interaction with the player. When interactable is set to false, the transition state for this button element will be set to the disabled state. And it's time to talk about transition options. The transition here means that the button switches to different states depending on your actions. By default, the button element will display the normal state of the button. The look of the normal state is automatically set by the image component attached to the button element. Depending upon the transition mode chosen, a button can also display a highlighted, pressed, and disabled state. There are four options here, let's discuss each of them. The simplest option is the none option. It means that whatever we do, the button will not show whether we have pressed it or not. However, at this moment the button works and it will execute all methods that you have assigned to it. The color tint property changes the color of the button depending on your actions. A highlighted state is set when the pointer is hovering over the button element. It is not pressed yet. When the button is pressed but not released, the button switches to the pressed state. If it is released, the button switches to the selected state. Very easy. The disabled state is set when the button element is not interactable. To switch to the normal state, you need to click on any other object or just click on any point outside the button. With the color multiplier, you can brighten the colors that are overlapping the button image. I'm not sure if this option is popular, but if you want to multiply colors, you can use it. To do this, you need to change the property value by moving the slider. The fade duration is the time in seconds a transition takes between states. The larger this value, the slower the button will react to clicks. This is a good way to make the player very angry. Just increase the value of this property and the player will throw away the mouse or break down the keyboard. The target graphic is the image component that we want to highlight. In almost all cases, this will be the image component attached to the button element. If I drag another object to this field, the rules defined in the transition states will be applied to the new target object. The Sprite Swap property works the same way as the tint color property, but instead of colors, we can change the sprite of the source image property. Let me activate the Sprite Swap object to explain this property. So the Sprite Swap will use different sprite images for each state and swaps them depending upon the state of the button. In this mode, a new graphical element is required for each state. I have dragged some sprites to the fields. Let's see how it goes. If I hover my mouse over the image, then Unity changes the sprites. If I press the button, we will see another sprite, and if I release the button, we will see another sprite again. To switch to the normal state, just click somewhere outside the image. When the button is not interactable, we'll see the disabled sprites. Let's move on to the next property. It is the animation property. It is a bit more complicated, so let me activate another object. Okay, what do we have here? We have the button with the magician sprite in the source image property. The animation option is active and we have these 5 triggers. The normal state, the highlighted state, pressed state, selected state, and disabled state. Each state has an individual name. I will explain a bit later what these names mean. We have an animator component attached to the button and an animator controller direct to the controller property. This button anim controller manages animation clips. I have created simple animation clips using the sprites you can see in the project window. Let's watch these clips, highlight the animation object, and let's have a look at the animation window. I have created 4 simple animation clips: the run clip, the idle clip, the die clip, and the jump clip. In each of the clips, the sprites replace each other to create such simple effects. Except for the jump clip. Here I am changing the position of the magician, thus creating a jump effect. Nothing special. Let's have a look at the animator window. The default state clip is the idle clip. The any state here is the option that helps run all other clips when we set true to the one of the triggers. In this case, we don't worry about which clip is active when a player hits the button. I have created 4 parameters, all of them of trigger type. Parameter names are the same as the names of the button states. It's important, the names must match. Each trigger controls a transition between clips. Let me activate the transition between the any state and jump clip. I have no exit time here and the transition duration is equal to 0. And I have only one condition. When the jump parameter is true, Unity will play the jump clip. The jump is true when the player highlights the button. When a player presses the button, the run trigger becomes true and Unity plays the run clip. When the button is released, the die trigger becomes true and Unity plays the die clip. It's a very simple structure. Jump and run animation clips will be looping. Okay, let's check it out. Click on the play button. When I highlight the button, the magician is jumping. If I press the button, the magician is running, and if I release the button, the magician dies. To run the idle animation clip, I will click anywhere outside the button. Cool. I hope it is clear how this transition option works. We can move on to discussing another property. Let me activate the bomb image. Let's imagine that when I hit the bomb, I want it to explode. None of the tools we have used before can help us. To solve this kind of problem, we will use another option. We can add an event to code the behavior of the button. A new event system is added to the scene when the canvas is created. When the event system detects a press and release over the same button, the OnClick event will be called. Clicking on a button is an event, and when this event happens, we may do something else. For example, we can call a new function. This function can be one of those created by developers, or we can create the functions ourselves. To add a new function to the function list, click on the plus icon. To remove a function from the function list, click on the row containing the function, even if there is only one, and then click the minus icon to remove it. Okay, what do we see here? The bomb image has the button component and the boom script attached to it. The OnClick event is not empty. I have dragged the OnClick object to the object fields. When we drag the game object to the game object field, the event system sees the functions that were created inside the game object and its parent objects. We can call those functions when the OnClick event occurs. I have called the blow up method. Before I open the script to explain its statements, let me show the explosion effect. This is how it works. I'm going to instantiate this explosion object when a player clicks on the bomb image. Remove the object from the scene and let me open the script. I will not focus on C# issues in this video. If you are new to coding, I hope you will be able to watch this video one more time when you feel you are ready. Now let me explain briefly what the boom class does. The ability variable stores the explosion prefab. It is a serialized field, so I shouldn't forget to drag the object to the inspector. The blowup method performs two tasks. Firstly, the method instantiates the explosion object. Secondly, it destroys the bomb. Very simple. Open Unity, let me check if the explosion object is in the right place. Good. Click on the play button and let's see how it goes. Okay, when I click on the button, Unity calls the blowup methods instantiating the explosion effect. Thus, you can execute any method or several methods when the player hits the button. Cool. We'll talk a bit more about bombs and events at the end of this video. Now let me activate buttons to explain the navigation property. So what it is all about? I believe it's better to show and then I will show you how to set it all up. I have a bunch of buttons here. One of them is highlighted green. It means that this button is selected and I can use the keyboard arrows to move between these buttons. I can go right and left, hitting the left or right arrow keys. If the second button is selected, I can go down and I can go up. But I can't go down if another button is selected. This is actually what the navigation option does. It creates rules for switching between buttons. It helps when using any non-pointer or touch-based devices such as keyboard or gamepad. So, how this works? If I click on the Visualize button, I will see all connections between buttons. These yellow curved lines show which button can be selected next when the player presses the keyboard buttons. The buttons located at the top are connected only horizontally. The buttons below the second button are connected only vertically. If I select one of the bottom buttons, I will see that its navigation property is equal to vertical. The vertical here means that I can only switch from button to button vertically. For this, I can use, for example, the up or down keys. If I select one of the buttons placed horizontally, I will see that its navigation property is equal to horizontal. I can move from button to button using the right and left keys. You can set other keys if you are using a keyboard. To do this, click on the Edit button and select Project Settings. Select the Input Manager. You can set any keyboard buttons to negative and positive buttons, if it is more convenient for you. I will leave it as it is, and let me close the Project Settings window. I will highlight one of the buttons and open the navigation pop-up menu one more time. The none value means that the selected button will not allow you to use a keyboard to activate another button. Let me set none to this button. The yellow curves are gone. The everything value is the default value. It means that there are no horizontal or vertical restrictions. The explicit value means that I can manage the navigation manually. For example, if I drag one of the buttons to the Select on Up field, a player will be able to switch from the selected button only by pressing the upper key. In this way, I can select the button I have just dragged to the Select on Up field. Okay, let's check it out. Select the button and try to use keyboards. I can select all buttons placed horizontally using the left and right keyboard buttons. To select the vertically placed buttons, I have to select the second button and then I can use up and down buttons. Okay, the last button allows to move only in one direction. I have to use the up key. If I hit other keys, nothing happens. Cool. One more thing is worth mentioning. I have used a mouse to select a button the first time, and only when one of the buttons is selected I can use keyboard keys. It doesn't make sense since the navigation property assumes that there is no opportunity to use a mouse. So we need to clarify which button will be the first selected button. To do this, I can use the event system object. The event system component has the first selected property. I can drag a button to this field so that when I hit play, Unity selects the dragged button automatically. Let's check it out. Good, this time I haven't used a mouse. Let's move on to the last part of this video. If you have watched this video up to this point, then you are real heroes. We don't always need to use a button to interact with the player. There are many alternatives. I want to tell you about one of the forgotten ways to respond to clicks. Let me activate objects. So what do we have here? All objects are image objects. I haven't used the button components. When I click on the sender object, all bombs will explode. Let's check it out. Good. The sender object has the sender script attached, and all receiver objects have the boom script attached to them. Let's open the boom script first. We have already discussed this script. I haven't changed anything here. The boom class has only one method, and this method instantiates the explosion effect and destroys the receiver object. Let's open the sender script. The myEvent variable of Unity event type creates an event window in the inspector window where we can add receivers. The sender class derives from MonoBehavior class and implements iPointerClickHandler interface. The interface forces us to use the onPointerClick method that detects clicks. If a player has clicked on the image object and if there is a receiver attached to the myEvent field, the invoke function will call the method defined in the function field. In our case, this function is the blowUp method. Each receiver object will get a message that the player has clicked on the sender object. Open Unity, let me highlight the sender object. We can see the myEvent window in the inspector window. Here I have added receivers just by dragging receivers object to the objects fields, and I have called the blowUp method. The blowUp method is a member of the boom class. Okay, let's see how it goes one more time. Good. All receivers got the message from the sender and have executed the blowUp methods. Well, that is all I wanted to tell you about the button component. I hope this video helps to use the button component more effectively. See you in the upcoming video.